Call Peter Mackenzie on speaker. This is the worst start for a webinar ever. And this is totally not scripted, by the way.
So to the attendees, if there is any specific...
Hey, Peter, are you joining the webinar by any chance?
Oh, yeah.
Oh, you're saying, oh, yeah?
Yeah, I'm joining now.
All right, see you soon. Bye.
Perfect. Perfect.
That's the best start for a webinar ever. I mean, granted, now it's on the dot, so it's not like we're even cutting close. So yeah, hey, welcome everybody to the webinar, which is almost everybody is here together, and we are ready to go. Yeah, we have quite a good one for you today, and let me see if I can share my screen and all, and we can get started on the dot. All right, so can you see my screen first of all? If somebody could hit the chat and, you know, let us know if you can see the screen, let us know how you're doing, all of that. I'm getting a thumbs up from Mr. Crane. So yeah, thank you for joining. Thank you for our expert panelists, minus Peter Mackenzie, who we just called a minute ago, and he's joining momentarily. Not that he had forgotten or anything, but he'll be joining us very, very soon. Today, we're going to talk about Wi-Fi 6E, as well as private 4G, maybe also private 5G, or maybe private 5G and also private 4G, whatever. And we have Dean, Jeremy, and JR. I'll let you, introduce yourselves. Just a word of warning, this webinar will be recorded, just so that you know, okay? And the recording will be sent to you with the follow-up email as well after the webinar. So even if you take off now, I know it's beautiful weather here and in Texas, as we heard, and in Greece. So by all means, it's going to be a 6-person panel. So this is just your average mayhem warning. We never know what's going to turn up, and turn out. It's going to be 6 enormous egos. So we'll be probably just talking on top of one another for a good 60 minutes. Yeah, I'm Jussi, and with me I have Jerry and Joel. How are you guys doing?
Fantastic. Super stoked about our very first webinar, and thrilled to be here.
How are you, Jerry?
I have mixed feelings about this. No, I've of course I'm thrilled to be here, and yeah, especially excited to be on the first Hamina webinar.
You were totally reading that from the prompter, like, I am totally excited to be here. The truth came out before that, man. And then we'll start with Dean. Dean, how are you, man? How are you? And if people want to contact you, what do you do, and how can people get in touch with you?
Yeah, so I'm an industry analyst and advisor and general loudmouth about the wireless industry. You can find me probably easiest either on LinkedIn or Disruptive Dean on Twitter. And so, yeah, I just sort of spend my life talking about 5G, 6G, Wi-Fi, spectrum policy, bits of stuff on fiber broadband, and yeah, frankly, anything else I fancy. And yeah, so in particular, I've been covering private cellular networks since 2001. And Wi-Fi from about the same point. So, this whole sort of 5G and Wi-Fi thing, I've heard it with 4G and Wi-Fi and 3G and frankly 2G as well. So it's always good to have the next round of it. The only thing I'll say is at the moment, I'll throw in a bunch of other wireless technologies. So satellite crops up a lot at the moment, and various sort of low power wireless for IoT. So I'm sure we'll touch on some of that, and maybe some of the policy issues around spectrum as well that are pretty critical.
Sounds great. Thank you, Dean, for joining, and highly recommend following Dean. He posts a lot, and a lot of it is conference updates, summaries, all kinds of like industry insights. So highly recommended. Jeremy, how are you, my friend?
I'm very well, thanks, Jussi. I am based in the US, even though my accent is obviously from the UK. I've been building wireless networks for over 20 years. A lot of that was spent doing some quite weird and wonderful stuff because my focus was the events industry, building all of the network connectivity for a lot of high profile music festivals and various other corporate events. And I came to Private Cellular after 15 plus years in Wi-Fi because I was looking for ways to solve a problem that we had with connecting applications like point of sale and RFID scanning that is used at events. Wi-Fi was challenging for that, especially in the time constraints we operated under. So cellular was always had been a long time goal. Started looking at that in 2017. Fast forward to 2019, and some folks from Solana brought me some gear to test at AWS Replay. I tried it out. I was thrilled to learn that what I suspected was true, that it was definitely a valid option. But it was a little too early for the industry. So fortunately for me, I then spent the next 3 years at Solana on the technical marketing team. And earlier this year, I went back to being freelance once again. And now I'm working with vendors on their marketing content, and also getting back into building networks for events again.
Well,
the World Cup's coming up soon in America, so I really want to be there.
Thank you for joining so much. And Julia, side note, or Jerry or Joel, Peter is asking, how does he join? So it is going. So just
I got him.
For the attendees who just joined, we called Peter Mackenzie 1 minute before the hour and, asked him to join the webinar. And clearly we haven't even sent him the invite link. That's very likely on my plate. So I apologize on Peter's behalf. But thanks JR for joining. Hey, and the topical thing of the day is Happy World Wi-Fi Day, but I don't know if I don't even know if it's today, but I'm not gonna give out flat comments about blah blah blah. But I am. To celebrate the World Wi-Fi Day, not that it's a consequence or anything, but today we announced our stadium planning feature, and also any complex 3D environment. So you can now build stadiums and auditoriums and all kinds of complex environments in our Wi-Fi and private cellular and IoT wireless planning tool. So if you want to check that out, go on Twitter, LinkedIn. I just posted a video about that a couple of hours ago. So enough of the shameless commercials. And I can totally see how on the chat people are already it's already 7 past the hour and still no beef. So let's get to the beef. And and when Peter joins, please let me know and he can introduce himself. But here we go. So let's start the show with Under the Bus Challenge. All right. And we want a quick overview of both private 5G and Wi-Fi. And do I have a couple of volunteers for this? Jerry and Joel totally do not know about. Dean, even better. So give us an overview of private 5G in 150 seconds. You only have 150. Jerry or Joel, can you clock Dean for 150 seconds? 2.5 minutes, all right? I will give you some pointers here. Actually, you need to talk through the bullets, okay? So,
okay. With the bullets, okay.
With
fine.
the bullets. Time starts now.
So at the moment, there's a lot of private 5G going on in some countries, and I would say highlight particularly in Europe, Germany, UK, probably Finland, and then elsewhere, Japan, Korea, US up to a point. There's a lot of it is still 4G deployments and 5G trials. We've only had full 5G, both the radio and devices and standalone core networks suitable for private networks for about 1.5 years. I'll come on to sort of talk about whether these are purely dedicated or partly provided by a service provider a little bit later. There's dedicated spectrum or dynamic spectrum in some cases available in different markets. So CBRS and 3.5 gigahertz in the US, 3.7 to 3.8 in Germany, and I think Sweden now as well. 3.8 to 4.2 is likely to be an important band across Europe, starting with UK and Norway, and a little bit of it in France. And then there's various other allocations around the world. UK has a couple of strange, unusual bands as well, including one at the 1.8 DEC guard band that's been around since about 2006. So Private 5G is got a lot of different spectrum bands with local licensing. Unfortunately, they're all slightly different rules and approaches in different countries, so it's very difficult to create a global footprint for private networks at the moment. They do require suitable devices, and that requires the suitable spectrum capabilities in the radio part of the device, SIM and eSIM capabilities. Apple in their recent iOS announcement improved various private network capabilities. Various Android devices are also there. IoT is slower, but depending on where you are, what devices you want, you can certainly get it for sort of vehicles and high end, but you're not going to get low end IoT. We're probably running out of time fairly shortly.
Yeah. How much time, Joel?
It's
like negative 20 seconds, but he's doing great. It's
okay,
fine.
It's primarily Private 5G is used outdoors. For sort of campus environments, some indoors. It may or may not be combined or conversion of Wi-Fi. That's something we'll touch on later on. There's an argument to keep them separate, and there's another set of arguments to keep them together. So that was completely unprepared. I'll hand it back over to you.
Excellent. Thank you so much.
Actually, next time you do that, I did a course in improv comedy, and they do they do like 150, then they say right, now do it in 75, and then they do it again, now do it in 37, now do it in 18, now do it in 9, now do it in 4 seconds.
Excellent. We'll do that next time around. Who wants to do same for Wi-Fi 6E? Oh, Joel, thank you for raising your hand. Much appreciated. Yeah, Joel is okay.
Do you have bullet points for me, or no? You're going to go with Jerry. Okay, that's fine.
No, you were shaking your head. So and Jerry was laughing. So the ball went back to Jerry. All right, Jerry. You have Joel, time him. 150 seconds. Go.
So Wi-Fi 6E, 150 seconds. So it uses the 6 gigahertz band. So it's Wi-Fi 6 in the expanded into the 6 gigahertz band. Varies based on countries. So depending on what country you're in, how much spectrum you get available, up to 1200 megahertz of additional spectrum. Then you have WPA3, that's a requirement to be able to use Wi-Fi 6E. That either means you need to use the WPA3 or open enhanced protocols. It's going to be ideal for things like very high density deployments, where you need that additional spectrum and capacity. It is shorter range. It's a higher, shorter wavelength, so shorter range that you're going to get out of it, slightly less than what you'd see in like 5 gigahertz, but similar to that.
Joel, continue.
What else?
I wasn't paying attention because I was on Twitter. Sorry,
go,
we have
go,
130 seconds.
Oh, the classes, the classes for Wi-Fi 6E, AP classes, that's new to Wi-Fi 6E, where we have low power indoor versus things like standard power. Today, basically the only thing we have access to is low power indoor, but standard power is right on the kind of cusp, which will require AFC to be able to use standard power APs. Yeah. What I missed?
Right. Excellent. Thank you. And hats off to both of you guys. And also on the webinar, we now have Peter Mackenzie joining. Peter, in 10 seconds, give us an introduction of yourself, and thank you for joining. At least I saw him join, but is he a panelist?
I think something happened. I think we lost him again.
Okay.
We'll see if he comes back.
We are moving forward then. First, oh, there is Peter. Welcome, Peter, and thank you for joining.
Hey, I don't think am I a panelist or not?
You are now.
Oh, okay, that's great. Thank you. I've been trying to figure out how to join.
Sorry about that. Totally my bad, Peter. But thank you for joining. So first, let's talk about. There you go. So real quickly, most people know this, but how would we summarize kind of like the success of Wi-Fi 6E? I think it looks pretty good. Even 500 megahertz is a ton. and you know, many countries are considering or adopting more than that. So I mean, I would say this is globally quite a success story. What do you guys think?
Yeah, I think globally it's been quite a success story. I was looking at some statistics from an event in London just a couple of weeks ago. Full Wi-Fi 6 deployment, and out of about 15,000 connections, there was 10% at 6 gigahertz. So, and it was at different points during the event, it always seemed to be about 10%. So I think that gives a good indication of roughly how many 6 gigahertz capable devices now.
Absolutely.
What was encouraging though was about 98% of all the 6 gigahertz capable devices connected at 6 gigahertz.
So good.
And that was in London. So if you think about that, that's means that the devices are not only discovering 6 gigahertz, but are also choosing it and connecting at that speed if they can. So I think that bodes well for the future in terms of our device is going to be able to discover and connect at 6 gigahertz.
Absolutely.
I'm just going to jump in quickly on 6 gigahertz. Be aware that there's a huge amount of politics around 6 gigahertz at the moment. In different parts of the world, yeah, the whole band is 1200 megahertz. And I think I saw the slide there. Oh, you've got the slide. And it's in some of the world, it's all available for Wi-Fi use, an unlicensed band. In some parts of the world, it's the lower 500 meg. And in some parts like China, it's not there at all. There's a huge amount of wrangling that's going to be hopefully sorted out in November, December at World Radio Congress, but expect lots of politics. All the 5G people want as much of it for national licensed use as possible. Wi-Fi industry wants it for national ubiquitous unlicensed, low power and standard power. You've also got the satellite people, the fixed link people, the Earth observation people, and probably a bunch of others I've forgotten about, all of whom are sort of shouting about either incumbency or what they're going to do with it in future.
Yeah, that's right. And I think what we've got to hope, Dean, is that just like the sort of 5 gigahertz band has slowly, I remember going back sort of a number of years when we had different bits of the 5 gig band in different countries, and eventually countries have sort of unified on it. I'm hoping we'll get there with the 6 gig band as well, but I think it'll be a more difficult process with 6 gigahertz because there's much more players involved.
Yeah, I think you're going to end up with the Americas going full 1200, China probably not at all, and then, well, Europe it's all to play for, and then various other bits of the world is going to be variable depending on who leans on the regulators most between Wi-Fi Alliance or Dynamic Spectrum Alliance or GSMA or anyone else, or GSOA from the satellite side.
Yeah.
So, I think though, even like in Europe, we're going to just have or we do currently have just a 500 meg. I think that's still a benefit. It depends how you view it really, but if you view it as an extension of the 5 gig band, from a capacity point of view, it effectively doubles the amount of spectrum we've got available.
Oh, that's great. It all depends on sort of how far it goes. If you get the full band, then you can start doing, usefully doing 80 and 160 megahertz channels in whether it's industry or maybe for really high density usage and so on. It depends how many channels you want to have on a neighbor basis, but I'll let someone else talk about that.
Absolutely. And if we are we already touched client devices, and here's an interesting anecdote. I was speaking with a Wi-Fi expert from the higher ed, and he said by the end of the year, 25% of our client base will be Wi-Fi 6E enabled. Because of our student device policy, in 4 years, everyone will have a Wi-Fi 6E compliant device, as well as 70% of the staff. So that's a bold claim, and I buy that, of course, in environments like that, where you can control the client base. So here's one of the hot topics that always pops up in September, and I've been pretty bullishly pessimistic about this, and I'm a little bit pessimistic about the whole, will Wi-Fi 6E still be in the iPhone 15, or does Apple still, because they're the ultimate conservative, they might still consider it's too early? What do you guys think? Because they already supported heavily the private cellular industry. And we'll talk about that in a second. But what do you think about like, are we going to see? I don't even know if it's the Wi-Fi or iPhone 15. I guess it is the next one. But is it going to have 6E? Dean, you go first. Or actually, JR, you go first.
I mean, as you said, Apple have developed a lot of really extended support for private 5G and private 4G networks. It's surprising, honestly, that they haven't added Wi-Fi 6E sooner. You know, a lot of this is a function of their own research, I would imagine, and no doubt they have it already in their buildings. But I think they're also tend to be, as a company, they tend to be improvers, not necessarily pioneers in certain areas. They're not always first. So, you know, it is somewhat of an issue, but to be honest, the use cases for Wi-Fi 6E, we need it in industrial devices as well, in the same way as we do for private 5G.
Yeah, I suspect it will probably have it, if for no other reason than just for sort of feature parity with the equivalent Samsung products or sort of last year's Samsung products.
Peter, what do you think? Are we going to see
yeah, I think we will do, because I think you've got to look at the pattern for Apple, and they've started putting it in. They've put it in the iPad, they put it in the MacBook, and they tend to, once they start to put a chip into their products, they tend to follow that through across their lines. So I'm suspecting we will see it in the products. I think, yeah, I just think it'll be in the next iPhone. I might be wrong, but that's the feeling I get from what they're doing in other products at the moment. I think if they hadn't put it in the iPad, I would be less hopeful. But I'm more hopeful the fact that
Jerry raised hand. Jerry, what do you think?
I'm very hopeful for it, and I do think it will be there. The only hesitancy that it recently has created for it is the latest MacBook Airs did not include Wi-Fi 6E, but that was a fairly small update. So I guess it's a little more understandable where it's just a larger display. I don't know all the other hardware details with it. But yeah, the fact that they're not updating 100% of their product line of every new piece of hardware to have Wi-Fi 6E makes me a little bit concerned. But I do think because of the fact that they put it in the iPad, it will be in the next iPhone, at least like an iPhone Pro should have.
Joel, your vote is still uncast.
Sorry, I didn't realize you were voting. I was chatting and stuff and not really paying attention to the webinar. But
this is like the second time in
I know,
minutes, man.
I know. Are we talking about why about the iPhone 15 and why, or the iPhone and why there's no 6E on board?
No, just like, will it have it or no? The next one.
I don't know. I mean, it's hard to say, but the fact that they're putting it on some iPads now is maybe that's kind of like a test bed for them, because I think there's a lot less risk in putting it on an iPad than on an iPhone. The stakes are really high with an iPhone. So that's my 2 cents.
I'm with you there, but also like iPhone, the connectivity quality is so critical, and it's so easy for people still to like misconfigure their Wi-Fi 6E network, stuff like that. I don't know, and the industry hates me for saying this, but I'm gonna say a definite maybe for this. I'm still not convinced that it will be there. I wasn't last year, I wasn't the year before, and I'm not now. So take it as such. This we already touched. So JR, what's the meaning of this for private cellular? The whole like Apple now better support. A, what does the better support mean in short? And B, what's the significance for private cellular?
Well, they've added in some features that they've learned are quite important over the years. And if anyone has any experience of deploying private networks right now, and you know, this is especially a factor in the US, your phone, we have one PLMN ID for CBRS, which is the private spectrum available in the US, 315010. And most networks are deployed using that PLMN ID. So in your private network, you're connecting to that PLMN, And then you might see another one and try to attach to that, or you could be you could have dual SIM and be out of the coverage area, but your phone will still keep searching for your private network, which absolutely destroys battery life. Anyone who has run dual SIM know that. And what they've done is they've added some features like geofencing. So, in this area, if the phone is in this area, the private network is available, attempt and attach. When you move out, back on public network purely. They've also added dual mode support. So your private network SIM will be data only, and that will be the preference when you're in coverage. And then when you're outside coverage, it will just go to your public network. But while you're in your private network coverage, you can still make calls on your public network. So if you've got, say, Verizon or Orange or whoever on your public network, or your calls and SMS, well, your calls will go over that, and your data traffic will go on the private network. So those are some of those are the key things that people are looking at. Just makes the user experience that much more seamless.
Yeah, it sounds like a huge user experience improvement for the most popular client devices. Do you know if Samsung and the other guys do similar things, or how does it work across the most popular end user devices these days?
Apple have been leading in this area. They were some of the first to add support for private network bands on their devices. It goes back to iPhone 11 and iPad Pros from sort of 2020. So they're definitely leading. As far as I know, they're the only ones to do this. Some devices have the ability to choose your cellular over Wi-Fi, but it's not specific around private networks. So it's very much a developing area, and Apple are leading the way on this.
Very good, very good. And here's from 2020, there was a posting from Fierce Wireless. So 90% of smartphones to support CBRS by 2023, says SNS Telecom. JR, are we there? Are we at 90%? At least the high-end phones do, right? But for the lower end, like volume ones, I would claim that the 90% of all maybe isn't there, but 90% of the currently shipping high-end phones. Yeah, what do you think? And followed by JR, Dean.
Yeah, I mean, briefly, I'll let Dean pick up on this one, but yes, broadly across, any phone released since 2021, really, the flagship phones of most vendors do support CBRS and other private bands. But we have seen a definite lack of support as soon as you go into things like Samsung A series, lower cost tablets, things like that. There's definitely a dearth of compatibility at that level. That's true. But Dean can probably.
And that's okay because they are not business user devices, probably anyway. Dean, what do you think?
Yeah, no, I mean, I would agree, and also I'd say that that's 90% of mid to high end smartphones sold in the US. I'm fairly sure if you buy a local phone in China for use in China, it won't support a US only band. To a large extent, particularly if it's a lower cost one. Probably the same in various other parts of the world. So I think it's worth saying that CBRS is a US only band, and it's a US only spectrum allocation, dynamic spectrum allocation mechanism. One question I've just seen here and it's important to bring out in the Q&A, was asking whether private networks are a replacement for DAS systems, and the answer is not really. It's worth pointing out that the majority of uses of private 5G and LTE are not for sort of visitors' phones to a hotel or to an office. Therefore, a CCTV camera at a mining site or various IoT devices, they may well be outdoors, so obviously distributed antenna is not really suitable. And it's there, and DAS systems are usually used for public networks, so a typical mobile carrier, an AT&T or a China Mobile or a Vodafone. Whereas private networks, the main use case at the moment is a completely dedicated network for a port or an airport or a mine or a warehouse, where they want to have the cameras, the robots, the phones, the handheld devices in a manufacturing environment. So it's a very different set of use cases. Where it gets more interesting in the future is whether you use a private network for what's called a neutral host, which is essentially providing public network coverage or in a private building, and we're not really there yet.
Fair. And so I just, to continue with the where did we land theme, we touched the client devices a little bit. So here's just, an illustration. Of course, it depends on the kind of limits of coverage and stuff like that. But certainly where we landed with coverage is that, CBRS or private cellular in general, excluding millimeter wave and all of that stuff for now, like private cellular, certainly like the usable coverage and reliable coverage is far greater per cell compared to Wi-Fi. JR, do you have like a rule of thumb, like, or how do you see the coverage thing, and how do you deploy for coverage? This is from our tool, but of course, it depends on the threshold, stuff like that. What's your take on coverage, CBRS versus Wi-Fi?
Yeah, I mean, I tend to work on a rule of it's for every 5 to 10 Wi-Fi access points. If we're talking about indoor, you're talking about one private cellular small cell. That's a sort of typical rule of thumb. Obviously, every building is different. The use case dictates how much coverage and the cell density. But yeah, between you can replace Wi-Fi APs if that's the goal in terms of similar coverage with one small cell per 5 to 10 APs.
Very good. Peter, have you deployed private cellular?
No, I have not deployed private cellular. I feel we're a little bit behind the curve in the UK compared to the US.
So this is an invite. Anybody who's deploying private cellular, invite with you Peter Mackenzie, and he will fly in, right?
Yeah. I guess that is an invite, but I guess the coverage question I think is only just one correction here, because we've also, as we know, with Wi-Fi, you're thinking about capacity when installing these things in build. So just because you can replace, 10 APs with one private cellular point, does that mean you're going to get the same capacity? I guess that'd be a question I have. Maybe Jo and Dean can answer that question, but
yeah, capacity wise, no. Especially if it's LTE 4G, the limitations are quite strict. It doesn't lend itself right now for high density, high capacity connectivity. That will remain a sort of Wi-Fi as the preferred technology for that. I don't see that changing anytime soon.
I think it's going to depend on the use case and the what it is when you talk about capacity, because there's some markets where you've now got private millimeter wave. The UK's got 400 megahertz available in 3.8 to 4.2 in many places. So you can do it, but that's often used for sort of specialist things like lots of high def cameras at a port. If you're doing remote control of the cranes for loading containers on or something like that. And that's very different to sort of density in a stadium environment for people with smartphones, for example. So I think that there will be point capacity, but it's not necessarily going to be the same use cases that you think of using Wi-Fi for. Also, you think about mobility as well and an outdoor.
That's what I tend to get. I think the people I've spoken to, at least in the US, who've been deploying CBRS, seem to be using it for the sort of wider area sort of coverage areas. So whether that's providing internet access in a school district to student homes across a wide area, or it's some sort of firming IoT related application where you want to cover large distances, that seems to be a very good use case for private cellular at the moment.
Yeah, I mean, to be honest, actually, one of the most common use cases I'm seeing, certainly in Europe for private cellular, is replacing private mobile radio. So Tetra, walkie-talkie, eventually, because a lot of that is expensive. It's near end of life, and it can only do voice and very low rate text. And so, if you want to give your security guards or your field workers a sort of a more sort of ruggedized smartphone experience with push to talk, push to video, and a bunch of data and cloud applications, then that's a use case. And so we often have this sort of debate about private cellular and Wi-Fi, but to be honest, it's private cellular and Wi-Fi and Tetra and P25 and Bluetooth and old point-to-point, microwave and n number of other things. So it's I'm not going to throw up a slide, but essentially it's a lot more to it than just Wi-Fi and private 5G. The other thing, actually, the other debate is private 5G versus public 5G. Whether you buy into the network slicing debate, arguments for that. I did an article on LinkedIn a couple of weeks ago. So at the coronation in London a month ago, there were 2 private networks running near Buckingham Palace, and one was a dedicated private cellular network for the BBC and a bunch of other broadcasters. Another was a slice of Vodafone's public network that had been done for one of the other broadcasters on a slightly smaller scale. So there's different philosophies and use cases emerging here.
Absolutely. And
yeah, and I think that's important, isn't it? The different use cases, because it's that's why I don't really see them as competing technologies. Everybody loves to have the argument, but they've in my opinion, they've got very different use cases.
Absolutely. And I mean, here, this is exactly like I would claim that Wi-Fi is pretty horizontal. It doesn't have its specific frequency band, and sometimes it struggles with things like voice, and it doesn't cover very wide areas, stuff like that. And CBRS often in specific use cases. I guess this would be kind of the oversimplification. Then I took a couple of snapshots from Grandview Research, as well as, and by the way, MFA, if you haven't been to mfa-tech.org, they have a good like state of private cellular data sheet. Jeremy's nodding. He's been reading it. Dean is like, I don't know if it's that good, but either way, here's kind of what we're seeing. So for private cellular, what we're seeing, what they're claiming is manufacturing 26%, so the biggest segment, transportation, education next, then mining, logistics. JR, this what you're seeing?
Broadly, yeah. I mean, I think Dean mentions a good case there where, it's an older system that's being replaced, but you couldn't move what was being done on Tetra to Wi-Fi. For many years in the events industry, I was always being asked, oh, can we put our two-way radios on the Wi-Fi network? And the answer is always just absolutely not, because that's a critical communication path and couldn't deliver the reliability required. So we're seeing older applications being moved onto private cellular. It just wasn't an option before. There are problems out there. It's difficult for network engineers. Problems that you couldn't really address with the technologies that you had to have. So with the advent of private cellular, you can start to move some of that critical application traffic onto wireless, possibly for the first time. So you can write industrial automation, all those things are fixed.
And how much of this is dedicated spectrum's benefit, and how much of this is protocol? For example, like is all of this because of the dedicated spectrum, or can we attribute some of it to like narrower channel protocol, or all this kind of stuff? How does it work out?
From my perspective, the way I see the key difference between private cellular and Wi-Fi is the way it's controlled. Cellular wireless is centrally controlled, the experience, how the traffic moves, where it goes, especially for devices that are moving between cells of coverage or between radio coverage, APs, small cells, whatever you want to call them. That's centrally orchestrated, which is something that is a complete change to Wi-Fi, which is distributed. The APs, the switches, the routers, all the different network elements are making decisions about how to handle traffic. In the cellular world, that's done in the core. So yeah, I think to the great extent, the reason that it's popular in these areas is the robustness of the actual cellular protocol and foundations that are built into it.
Jussi, can I share a couple of slides?
Please, Doctor.
All right, let me.
While Dean's doing that, I have actually, this is a Weavix two-way radio. So this is the next generation of two-way radios, and this operates on private cellular and public, of course. But
nice.
Those are the kind of things that are going to drive adoption, I think, in the market.
Have you got that slide up now?
Yep,
Yeah,
we got
yeah.
it.
I mean, the charts are like doing by vertical are okay, but you have to bear in mind that the private networks come up vastly different scales. You can have a private network which is one small cell, frankly, on a private jet or a ship, or one particular process in a factory, covering a few end devices. Or you can have the entire railway network or utility grid of a country running on a dedicated network. So you've got like at least 3, maybe 4 orders of magnitude in scale. So you try, and you also have differences between a lot of the manufacturing examples are prototypes. They're people testing it out, whereas the ones which sometimes get actually deployed in production don't always get a press release, which is what gets captured in some of the stats. So I noticed, for example, there was no defense segments on that slide. And also there's some sort of community fixed wireless access. Is that public? Is it private? You can debate that.
Yeah,
but
that's
certainly
true.
in CBRS and in parts of Europe, those are the main license holders of people providing fixed wireless. And so here you've got this sort of single small cell, one building or a structure or a small campus. Then you've got a big manufacturing plant or complex or resort or university, right up to sort of cities. There's now a number of metropolitan authorities deploying private networks in an area for their traffic lights or something like that. So there's lots of apples and pears and different sorts of fruit, and trying to compare all of them is a challenge. On that, just to point out that Jussi is not the only one to play around with Midjourney. This, even from an indoor point of view, there's very different sets of use cases in an airport terminal or a factory or a retail setting, both in terms of why you might want to use private cellular or Wi-Fi or both. The one last AI generated graphic from my side is the greenfield or brownfield. Is actually really important. If you're building like a new gigafactory for EVs or batteries or something like that, you've got the luxury of starting from scratch. You can do as much with 5G now, and you know the roadmap towards different releases in the future, so you can design around that. Whereas if you've got an existing plant or mine or whatever it is, you've got 1,000 devices which are running on Wi-Fi or weird IoT protocols, and you buy 5 automated vehicles. You're not going to change the other 1,000 overnight, and you're going to run with both in parallel for quite some time. It's really worth realizing there's lots of different dimensions for slicing this up. Be particularly wary when you look at the stats of the prototype versus production. So if you take, say, automotive industry, a lot of companies are building a small scale, if you like, test plant, not just for the network, but they've got the new welding machines, they've got next gen, sort of manufacturing processes, they've got, sort of ovens to do particular industrial things, and they've got maybe a private 5G network and a trialing Wi-Fi 7 in this sort of mini factory setup. And then what happens is when they bring it to production in 3 years' time or 4 years' time, they'll go to the big main plant and it'll actually be deployed properly. But having 2 small cells and a couple of Wi-Fi access points in their test factory, is that a manufacturing deployment of 5G? Well, it sort of is and it sort of isn't. So be aware that there's a lot of nuance here.
Yeah, absolutely.
I'm going to stop sharing these now.
So question on that, like kind of you referred to deploying this. So the design deployment of private cellular compared to Wi-Fi, and on the other hand, let's start with the easier one. Peter, can you talk through like designing non-6 GHz network versus 6 GHz network? What are the differences, if any, summarized? And then after that, the same question for JR, comparing Wi-Fi design deployment versus private cellular. So Peter, designing and deploying non-6E networks in the past versus 6E or 6 GHz capable networks today. What are the main differences, if any? Coverage is slightly different, but capacity is certainly different. What do you think?
Yeah. To some extent, the way you design a network, isn't going to change a lot in terms of you've got to gather the requirements, you've got to do some measurements, create an RF model, do your design, make sure you meet all the requirements. The sort of basic broad brush of designing isn't really changing. But is some particular considerations, I guess, to take care of. And I think a lot of it comes down to more, how am I going to configure the different bands, and what do I want to see happen? So, and I actually think what you can configure today may not be what you configure moving forward, but given the number of clients. So if you're going to deploy 6 gigahertz, what do I want? Well, I surely want my 6 gigahertz devices to connect at 6 gigahertz, because there's not going to be as many of them. It's going to be not as congested as 5 gigahertz. I'm probably going to get better performance. So how do you achieve that? Well, a lot of devices, if you look at the criteria for how they select a BSS to connect to, a wireless network to connect to, is most of them now are considering the throughput they think they're going to get on the AP. So it's not just signal strength. Most of the algorithms, Android do that, Apple do that, they look at many factors. So how can you make 6 gigahertz more attractive? I think one way is by having wider channels. So if you're deploying 20 meg channels in 5, and then you deploy, say, 40 meg in 6 gig, or if you've got the full 1.2 gigahertz of spectrum in the US, you might have 40 meg in 5 gig, and you might have 80 meg in 6 gigahertz. The clients will more likely connect to 6 gigahertz, and that can be quite a good way of ensuring that your 6 gigahertz clients move to 6 gig without having to do anything too complicated.
The question is, the deployment you just saw, was it in London?
Yes.
Didn't they maybe have 40 megahertz channels on both? Or...
No, they had 20 in 5 and 40 in 6.
Okay, 20 and 5. Okay, yeah, that would have been nice to understand also, like 40.
Yeah, it would have been nice to understand that, but I think I can see why they did that, because what that did, it ensured that they got 98% connected of capable 6 gigahertz devices connected at 6 gigahertz. I think that's a great success for that model. The other consideration is, of course, what security you're going to have to deploy, because in 6 gigahertz it has to be WPA version 3. You don't have a choice; that's mandatory. So you're going to have to, if you're going to have the same SSID across, say, 5 and 6 gigahertz, you're going to have to have a least transition mode in 5 gigahertz to be able to cope with your older 5 gigahertz devices. Because if you just go, if you just decide to go, WPA version 3 in both bands, any older devices that are still using the 6 gig band, sorry, the 5 gigahertz band, may not be able to connect.
Yeah.
So you've got to think about how we deploy our SSIDs. I think needs a lot of consideration, and I think that's something that's going to be different in design.
It's more of a configuration thing. Jerry, J Dog, aka Jer Bear Allah, you have your hand raised. Is that a legacy hand raise, or you want to fire?
I did. Yeah. Thank you. No, one other thought I had on that, I'm curious what your thoughts are on this, Peter, is I still see a lot of people designing Wi-Fi networks without even considering Wi-Fi 6, as in 802.11ax, right? And the benefits that come with that technology. In particular, what I mean by that is, with Wi-Fi 6 introduces MCS 10 and 11, and to really get those high data rates, we really have to carefully design where those APs are in proximity of the clients. So, for example, putting APs, outside of the room and in hallways, things like that, we're not going to get those high data rates where the actual majority of the users might be connecting to that AP. So I think that right there is a fundamental shift from what a lot of people are still doing today. That's not specifically related to 6 gigahertz. That's just that we're still kind of designing for 802.11ac and maybe 802.11n, or maybe we're just ripping and replacing a network that was designed for that, and we're hoping for the best of Wi-Fi 6, Wi-Fi 6E, because what I'm seeing is a lot of organizations were kind of holding out of not upgrading to Wi-Fi 6, and they're now finally going from Wi-Fi 5 or AC to Wi-Fi 6E, and they're jumping over that Wi-Fi 6, and they're not actually even taking that piece into the equation. So a lot of people aren't going from Wi-Fi 6 to Wi-Fi 6E. They're going from really Wi-Fi 5 to Wi-Fi 6E.
Yeah, I think it's a valid point. I think I would even argue that people when designing properly for AC, in terms of putting APs outside of rooms, and therefore not making use of the higher data rates, because obviously the lower data rates go further. So there has been a perception for people who've been designing wireless, even from the ABG days, even go before N, about the sort of distance you get with Wi-Fi. And while those distances are still true, you're only going to get them at the lower data rates. So the number is an education piece, I think, on design. You know, I constantly say my number one rule is place the APs as close to your users as possible. And you'll get a lot of people cynical about these higher data rates and higher modulation methods and go, oh, you've got to be within 1 or 2 meters from the AP. But actually, a good designed Wi-Fi, if I'm in a conference room, ideally I want the AP in the room with me. And if it is, I may well only be like 3-4 meters from the AP, and I can get those higher data rates, and I can get those QAM levels. And actually, I've designed networks where people are getting them really well because the AP is above their heads, and there's not, you know, and you can get those levels, I think, if you design Wi-Fi and just remember, place the access point as close to the users as possible. Number one rule. And we should be doing that from, you know, AC, AX networks. That's what we should be doing.
And that is one of the absolute key benefits, as it turns out, of AX is actually just that higher QAM that you get. Some of the other benefits, you know, a little more, but definitely the higher QAMs.
100%. I did some testing with 6 gigahertz on an 80 meg channel, and I was getting over 800 meg throughput. That was throughput, not data rate, you know, and consistently. So it's pretty good.
So JR, how would you compare? You've complained, or you've deployed a boatload. This is where my Finglish and a long day comes in. You've deployed, JR, a boatload of Wi-Fi in the most difficult of environments, as well as the regular type, and now with private cellular. How would you correlate those two? Do they correlate? What are the main differences? What are the main similarities? And can you break some of the myths that people have maybe that are, you know, making them afraid of deploying private cellular?
Sure. Yeah, I mean, starting with that one first, someone did ask about training resources. There is a link on waveriderswireless.com to some various cellular network and training resources, most of which are free, that people can get into and start learning about this. I think anyone who's in Wi-Fi can learn this stuff. Don't worry, you know, if I can learn it, definitely you can. You know, I fail at the math part of Wi-Fi. But speaking about the math part of Wi-Fi, one of the big differences, I think, between engineering for a private cellular network versus Wi-Fi is we're designing to a vastly different signal strength. So Peter, you can probably confirm, I think the standard now for 5 gig and 6 gig is your target is neg 65 to the device. Ideally, is that about right? That's what you're looking for, right?
A lot of people design to that level now, yeah, in enterprises, yeah.
So, you know, that, I mean, they will work up to neg 80 or more, but, you know, that really is your limit. In Wi-Fi, we can, depending on the system, we've got up to neg 120. That's how we get that, that vast coverage area. Yeah, and that's one of the biggest factors. Also, the device side. In the Wi-Fi world, we're always competing with the least capable device, right? And unfortunately, those least capable devices make really bad decisions about what to connect to and when. But in a cellular world, as we said, that's centralized. You know, there is centralized control telling the UE in our terminology which cell to connect to for the optimum experience, and manages the transition between those cells. So there are some differences there. Again, you know, the same rules apply. What is the application? What is the environment? You know, what are we looking at the very basic levels? All those basic skills most folks in Wi-Fi already have. But yeah, we're designing for a different capability on the UE, and after that, everything is dependent on the application and the environment.
Excellent, excellent. And what about setting up the whole system? If you had to like describe in short, setting up private cellular versus setting up Wi-Fi and kind of the configurations, what are the main things to consider there besides RF and signal strength, that kind of stuff?
Yeah, today there's a couple of different approaches out there. You've got folks who are trying to replicate a Wi-Fi-like experience. You have a controller, you have access points, you manage them via some kind of online or web-based orchestration. And then there are the other vendors, the more traditional ones, like Nokia, Ericsson, those folks where it's a lot more complex. And I'll throw Cisco in there as well. Their network architecture is so complex that they literally can't let anyone deploy it themselves. It has to be deployed as a managed service. So there's a lot of different experiences out there. You can start at the bottom and get some buy cells equipment and deploy your own. It's actually pretty straightforward. Again, mostly web-based interfaces, and as long as you know the basics, you can get to it. But the small cells connect to switches. They're typically connected, powered via PoE, same as a Wi-Fi AP. Until you get outdoors, then you need power, but you can have much more transmit power, so you need more input electrical power. But essentially, architecture, as I was saying, we have in the cellular world, obviously, it's not pure IP in the same way as it is in Wi-Fi. There's some differences there, but your gateways connect the enterprise network with the cellular network, and depending on the vendor as to how much integration you can achieve. It was basically the same.
Very cool, very cool. So I think we're getting towards the top of the hour, but before we go to closing words from everybody, Joel and Jerry, do we have a few frequently asked or otherwise quirky or interesting questions from the audience?
We do have some questions, although Dean and JR have been answering them pretty much on the fly. And so there's a bunch of answered questions in there for anybody that wants to go do a little bit of reading, which is fantastic. But there are a few that have kind of been hanging out here for a while that I think would be fun to talk about. First one is from Bruce Johnson. Bruce asks, how do private 5G implementations differ from Wi-Fi in terms of design and implementation? What's the comparative cell sizing? Are there verification tools? So maybe we start with the design and implementation part and work from there.
Yeah, and we just covered much of that by JR like a couple of minutes ago. But if you wanna summarize, JR, and maybe I'll show some of the design aspects while you talk using our tool.
Sure.
Shamelessly promote it.
Sure. I mean, I can independently say, regardless of the fact I've been invited on this survey, that I've been really enjoying using Hamina to design cellular networks over the last few weeks. I'm getting some basic level of proficiency, but essentially they're different in terms of coverage, as we already stated. Wi-Fi networks, you're targeting neg 75. We can go up to neg 120 in cellular, much greater coverage area. It's orchestrated, so you're moving devices move more easily. As for verification tools, limited numbers at the minute. There's something called the Prism PCI scanner, which you can use. It's a little backpack thing, fits on the back of an iPhone or something similar. If you check out Adam Wold, WOHLD on LinkedIn, he's got some interesting articles on how he's done verification using that tool. But those are basically, it's limited at the moment, but developing very quickly.
Jussi, do you want to speak about the planning stuff and maybe talk a little bit of roadmap for verification stuff?
Yeah, that's a really good question. So of course, our tool can or on the same project, you can design private 5G for different regions, Wi-Fi 6E, all of that, plus BLE, ZigBee, and Ocean, whatever. It's great. Try it out. Thank you, JR. You'll get your $20 later. I'm kidding. About the surveying stuff. So we will be releasing also physical on-site survey capabilities soon. And first it will come out for Wi-Fi, very shortly thereafter, also for private cellular as well. So JR, it'll be something for you to definitely give a shot as well. But yeah, definitely there's already solutions for that, such as the Prism and many PCTEL has scanners and many others. I know IB Wave can integrate with some of those. Or did I just say that? Oh my God. Anyway, so
I purposely didn't mention them.
well, I mean, always something for a friend, right? But yeah, any other interesting questions?
I had one to tag onto that one around designing for the 5G. I'm curious if, like, similarly what we were talking about before around different Wi-Fi generations impacts design. Does designing for 4G versus 5G, is there differences there as far as like density of devices, that kind of thing?
Maybe that's for JR.
Yeah, JR, do you know if there's differences between designing for 4G and 5G, or is it pretty similar from an RF standpoint?
It's pretty similar. 5G architecture can theoretically cope with much greater density, but that tends to be in sort of the millimeter wave type applications. But in a lot of the mid-band frequencies that we're seeing now, the small cells that we're seeing coming to market are sort of 100 concurrent users per small cell, and that's concurrent active transmitting data, etc. So, for density, you can actually in a cellular world just add more radios. Whenever anyone says that in Wi-Fi, obviously everyone in the professional world, puts their head in their hands. But in cellular, we can actually do that.
And I know we're about out of time, but there's one more question here that Keith asked on behalf of Danda that I'd love to hear the answer to. I have no idea where this one lands. But do private 5G radios can they use the same channels, or do we need to do like channel reuse like we do in Wi-Fi? Because with Wi-Fi we have co-channel interference that we have to account for. How does that play out in the cellular world?
A classic yes and no answer. JR, you want to take that?
You gonna give me that one, Dean? Don't you want this one?
Under the bus. This is your under the bus moment, man.
Sorry,
Everybody
guys.
gets thrown at least once.
Yeah, as far as I know, cellular doesn't have anywhere near the same reuse numbers that Wi-Fi does. In fact, that's been an issue in the regulatory meetings I've been to recently, where some of the cellular people say, "What, you use reuse of X number?" So my understanding is that it's usually not an issue, on the same channel or maybe two.
Yeah, it's the central control of cellular networks makes managing that sort of co-channel interference issue a lot easier because it is centralized rather than sort of done at the very edge. So it's typically in CBRS, a lot of your channel allocations and frequencies, how much bandwidth you can use, that's assigned by the Spectrum Access Server anyway. So there is only so much modification you can do in there in your channel plan. But yes, there is, depending on the use case, you do have to undertake some pretty significant channel planning.
Great. All right. Well, we're a couple minutes past the hour. I see some people in the chat have to run off for other meetings and things like that. So I know we have some questions here that we didn't quite get to, but I don't know. What do you think, UC? Do we try to cram a few more in here, or do we wrap it up and take those offline?
Let's cram a few more. What is a webinar that doesn't go over? But and of course we can let Dean, JR, and Peter go whenever you gotta go. You gotta go, guys. But before we end, I'd like to hear from each one of our three panelists. Like, what did we not cover that needs to be said where did we actually land with private 5G and Wi-Fi 6E? We'll start with Mr. Mackenzie. What's the missing thing that should be covered definitely when talking about the honest truth on private 5G and Wi-Fi 6E?
Well, I think something that does need which would be interesting to discuss, and I would love to hear at some point JR's and Dean's opinion on this. But JR has talked a lot about how cellular is network controlled, is centrally controlled, and with Wi-Fi it's distributed controls. Effectively, the client makes all the decision. Well, while that's true, the movement for, if you look at the latest standards in Wi-Fi, especially if you look at AX, and OFDMA is to try and push more centralized control on Wi-Fi with OFDMA, basically trying to take ideas from the cellular market. And my question would be, and we've already got time to discuss this, but is that a good idea for a technology that's so client distributed focused to try and push a centralized model on it? Will it ever work, or is it just going to cause more problems? That's something we haven't discussed, but I think it'd be fun to discuss.
I'll go for. I'll agree with that last one, and I'll say there's a couple of questions that came up we didn't talk about, which is around neutral host and where that fits into all of this. And in fact, that's on a general background here on the private 5G is what's the boundary between public and private? Where do service providers fit in? Do you have, if you like, the public network as a tenant on a private network, or vice versa? So that whole sort of intersections is something to explore another time.
Yeah, we could have a long discussion about neutral host. Yeah, I mean, in closing, I think, you know, the one thing that I would like to raise is a lot of people often ask me, okay, when's the hockey stick going to happen? When is the wide adoption of private 5G and private 4G going to happen? And I think, you know, there have been some barriers to that wider adoption. Some of which are self-inflicted by the industry itself. And I think those are things that can be changed. So, you know, I think it's fair to say that when Wi-Fi first came out, you know, the early 2000s, you could go out and spend a few $100s and have some equipment there and play around and see how it would work for you in your business and how you could use it. You know, network engineers tend to be tinkerers. They'll take stuff home, tinker with it, see what can be done, and then sort of make recommendations to the company. That's really hard with private 5G and private 4G because it's just not accessible. You can't just go on Amazon and order $300 worth of kit and start playing around with it. That's a problem. And that's a problem that the industry needs to address. They've focused primarily on customers they think are capable of deploying this, which has restricted a lot of their marketing and their messaging to the top 1,000 companies. Well, that's fine. They can do it, and they are deploying networks, test networks, proof of concept. But those take a long time, and they never, ever, ever talk about them, ever. And it's human nature that you need peer confirmation. You need to see other people doing the things you're interested in. And there isn't enough of that. There's a lot of talk in the industry about, oh, it can do this, it can do that. It can do it. Well, show me. I need to see it. I need to have some confidence, because if I'm going to enter like a minimum 50K POC, I need to know how this can be used and if it's effective. And I think the industry has done a really bad job of making that happen and making the technology accessible. So my challenge to them is, let's come up with some ways to get more people using this technology. That's what's going to create the momentum to drive wide adoption.
You're fighting a good fight, my friend. You're fighting a good fight, and I think this, you know, what you and some of the other guys are doing is going to benefit the industry so much in the long term. We appreciate you kind of you know, pioneering it. Well, with that, Jerry, Joel, any final thoughts before we wrap things up?
One final request is, JR, can we see your shirt clearly?
Oh,
nice.
That's such a cool shirt, man. Is that your own design, or?
I actually made it while I was at Salona. There's a few out there, not many, but there's a few.
Oh man, you need to make a second edition of those, man.
You know, it's my original IP, so there might be a Wave Riders version of this coming out. We'll see.
Excellent. And Jer Bear, what do you think?
I was busy signing up for the Wave Riders website, Wave Riders wireless website. So yeah,
so you want to drive us home, Jerry?
Drive us home. No, I think this is a good intro webinar to this kind of series that we're going to be doing of the dwell time series. So if there's any particular topics and stuff that you guys want to hear, definitely shoot those our way. You can hit me up directly at jerry@haminat.com. But yeah, if you guys have specific topics and stuff you guys would like to see us cover, but I think this is a good kind of general, topic where we hit on a lot of different things that, as we kind of discussed, we could spend a whole webinar talking about, many of these individual kind of data points that we hit on.
Absolutely. And next time, I guess we'll do large public venue, kind of stadium stuff, all of that kind of stuff. So maybe it will have a reappearance of JR in one form or the other. Maybe Peter too. Who knows? But anyway, thank you, panelists. Thank you, audience. This was pretty freaking great. And yeah, the webinar recording will be there. Maybe we should. I actually tried an AI-based transcriber today, and it worked amazingly. So maybe we'll actually transcribe this as well, and then we'll have ChatGPT make a summary out of that, and we'll send a ChatGPT summary to everybody as well. How about that? Combining AI tools with AI tools. Anyway, thank you, Dean, JR, Peter, my deepest apologies for screwing up your link to join, plus not letting you into the webinar. Well, we got here. I think it was amazing. Thank you, everybody.
Cheers.
Thanks so much, everyone.
Thanks, everyone. Bye now.
Bye-bye.